Welcome back. We are live again on Twitch, and once again, we have some great people from the product group. I once again had the honor to be with my Parisian coworker. I never get this honor, so I feel really great about it.
You'll get taller and taller after each session.
Don't hate that I keep growing. I'm seeing how you're hating on my growth. It is okay to be upset that I'm growing and you're not. It's really okay.
I am upset.
But we are here today to talk about a really exciting service. It's one that I've had so much fun with over the course of getting prepared for reInvent. So without further ado, let these great guys from the Rekognition product team introduce themselves.
Sure. My name is Marco Cagna. I'm a senior product manager for Amazon Rekognition.
Hey folks, this is Ranju Das. I'm the GM of Amazon Rekognition.
And well, I'm still Julian, and I'm here to ask questions, and let's get going. So, Ranju, thank you for being here. What's the elevator pitch for this brand new service?
Sure. So, as you guys know, last year we launched Rekognition Image.
Yes.
And the first thing customer asked us on day one, no pun on Amazon day one, that solve this for video for us. And specifically, there are really two stories that stand out. One is C-SPAN, and they were primarily dealing with video, large quantity of video, and they ended up having to create frame extraction from video.
Like C-SPAN did, right?
C-SPAN, yeah. That's a C-SPAN story. And they passed it to Rekognition Image. And the same thing was Scripps Network. They were extracting frames and passing through image recognition. What we found working with the customer is that the quality of that analysis is not anywhere near as good as a true video analysis would be, because the image misses on the context of time,
right,
as well as the context of motion of video. So we, as a team, sat together and said, we need to solve this for our customer. And we were very excited, because this was a very difficult problem. The context of motion, the context of time, the variability that video brings in was a really challenging thing from the team. We took it on. And yesterday we announced general availability for Amazon Rekognition. It's basically a video analysis service through an easy-to-use API for capabilities like object and scene detection, face recognition, inappropriate content detection within video, things like, is there explicit content, suggestive content. The two things that I am really excited about, and I think I would love our customers and viewers to play with, is the first of its kind of real-time person recognition against live stream.
Yeah, we're going to get to that.
We'll get to that. And then person tracking. Yeah. Those two I'm very excited about.
So I guess you've had customers testing this because, myself, I did get that same question. Oh yeah, nice, but when do you get video, right?
Right.
So any use cases, any customers you could already talk about using Rekognition video?
Pretty much from day one, I think the clear signal we got that a major part of the use case would be public safety. And part of the reason is the amount of data that's coming from public safety is so enormous. I think the projection is that by end of this year, there'll be 859 petabytes per day of video generated. That's like 200 million HD DVDs. So that's a primary use case. City of Orlando is a customer, was a launch partner with us.
Nice.
And the objective that they have is that for providing their city residents higher safety, they want all these public place cameras that are authorized by the city to hook into Kinesis video stream, and for Rekognition video to pull the streams and to do recognition of person. And the person can be person of interest, could be missing person. Kids are, a lot of time they're lost, and it's easy for them to track them and find them. So we are very excited with this partnership, and we can talk more about it at a later time.
Yeah, I will say that as a person who tried, before Rekognition video came out, to literally take a video, do FFmpeg, and try to grab frames. I actually did this, right, to grab frames and then send it out. The minute I started using Rekognition video, I was like, yay, I don't have to do some of that hard work anymore. So for me, this was it actually solved one of the problems that my customers and developers that we talk to was asking about, and me trying to give them a makeshift solution. This is actually giving them a real one.
Great
so it's fantastic, especially with the timestamps. It's great.
A video is not a collection of pictures.
Right, it's not. And
not.
No matter how hard I tried to make it be seamless, it wasn't. And then that context wasn't there. So it really was great seeing this come out. Yeah.
It is.
I think you got a demo, and
Yeah,
if there's one service that needs to be shown on screen, it's that
right.
one.
Given that we're in the business of video, it only makes sense that we'll show.
To
can we switch
the
the screen, please?
And show the demo.
So here, to set a little bit of a context,
thank you.
I'll show you this video. We took this video from a traffic cam that was provided to us, one of our customers. We pass it through our two APIs, our API for object detection, as well as an API for person tracking. And then we kind of visually stylize the representation of these bounding boxes that you'd get with our API to give you a very clean view of what you could do with our service.
All right, hang on to your hats. Here we go.
Let's hope the demo gods are with us. So you could see there's a car. We detected a car. We detected a dog. We detected a person one. I like the person one because we don't see her face ever.
Yeah.
And then other person, you
She's
see that you see the cookie crumbs behind them. So that was kind of the quick and.
What's funny is even as they were moving, right, it tracked their movement. But then I don't know if people caught that at the corner that I didn't even see with my naked visual eye that you caught that there was a dog sitting there. Yeah. So I thought that was interesting in playing with the service that you're literally even catching things that maybe people, because we have limited focus, right?
Yeah.
So you are catching things in the video that maybe I didn't catch that I could look at getting that content later.
And I think it's very important for our customers, right? Think of you are a retail store and it's about past the closing time, and you, through a sensor that you have, which all these malls and stores have, you detect a truck standing behind your store when it's not supposed to be. That is potential of a break-in, and you could react to it now because we are detecting things like trucks and cars. So we are very excited about that.
Yeah, actually, hopefully we have time. People want you to play the video again, but I have a question first. You guys have to wait. So talk about, so again, getting a chance to play with the service. I know a lot of our Switch viewers have not yet, right? So kind of tell us what are the key things on there. So I know, like, there is start label, I get the objects, and there's a different way of going about this than what you typically would do with the images. And that workflow, if you would talk about, because people who haven't played with it yet, if you could talk about the workflow that's just a little bit nuanced than using the recognition image.
Great question. So there are really two modes that we support with this video, right? One is video stored in S3, and inherently the challenge with video is they're a large payload, takes a long time to process. If you have a 10-hour video, it might take us a long time. So we've introduced this concept of an async workflow. And what we do is that you start a particular job. So for instance, you could, in this case, as you said, label detection. So we'll call an API called start label detection. Right. You provide us the S3 file that you want us to process. As a return, we'll give you a job ID. Then you make a call called get label detection for that job ID. If the job wasn't finished, we'll give you a status back saying that it's in progress, so you can keep polling and know what's going on. Once the job is completed, what you'll get is essentially a time series view of all the different objects and activities we have found. Now, we do support the same API, alternate projections. So let's say you didn't want the time series view, but you wanted to see when the dog shows up in every part of the video, you could switch in the request the projection to be a label-based projection, which means we'll say dog, and these are all the times that the dog showed up, or a car, and these are all the times the car showed up, which could be awesome for when you're doing an investigation on a video.
Sure.
Right,
now, the second mode that we support is this mode for live stream.
Now we get to the really crazy stuff.
Yeah, this is the fun stuff, right?
Yeah,
like nobody else did live stream, and we were very excited about getting live stream to our developers. So the live stream, the way we support, is working with Kinesis Video Stream. And the setup is the precursor to using our service, that you need to publish a stream to Kinesis Video Stream, which is also a product that launched yesterday. Once you have published a stream to Kinesis Video Stream, you come to Rekognition and you tell us that set up a stream for me with the information of the stream identifier that you have just set up, as well as a Kinesis identifier that you want our output to go to. Because again, the payload can be arbitrarily large, and we want to support a streaming real-time payload. Once you do that, then you start the stream processing. That's the second call you make. And then the last call is just put a Lambda function, start looking at the stream ID that you were the consumer for the stream, that Kinesis stream that they want to read at, and we start streaming the output of the faces that we have matched and the person we have found.
So I guess you're going to get that question, or you got it already. How, from a performance point of view, how far can we push this? What's the highest resolution? What's the highest frame rate that you could push into Kinesis, get processed by a Rekognition video, and still be real time?
Right. So we have, I think we have validated up to 1920p videos. We can still process them near real time.
Okay, so HD works.
HD works really well. Okay. I'm sure somebody would ask us, what about 4K? We have some plans. We'll look into that. We actually
of course, they will.
She will.
Yeah.
Put it on me. Come on.
Well, what's funny is that she's going to get out of the stage and ask me to build that. The thing with 4K, we just didn't find enough sensors to get the 4K streams. But yeah.
Okay, impressive. Really
right.
impressive.
So we're getting some questions on the stream, so I don't want to just not ignore. I'm not ignoring you, I promise. So let's talk about, I kind of know the answer to this, but I don't want to cheat. So I'm going to actually ask the question that is given to me. So what right now we're talking about, obviously this is synchronous nature of processing the video, right? I kick off my start label detection, and then I get a notification that's successful, and then I get the API. So someone wanted to know, how would I do that? What if I wanted the video to kick off with Lambda? So after I get this information, I want to kick off a Lambda API gateway to have the stream be maybe used downstream for some REST API or something else. Is that possible? Right now we're just talking about a sync, but how do I enable, just kind of trying to frame their question, other scenarios that are not as, I guess, as synchronously based? Can I kick off other things like Lambda?
So repeat the question, because
no worries.
Are you questioning the stream processor, or are you asking the question about the async workflow?
I think actually he's doing a little bit of both, so I'm going to read it exactly as he gave it to me. He said, he talks about, first of all, WebSockets. So we're talking about real time. And he said, what you guys are showing right now is all asynchronous, right? I'm going to read exactly as. So having WSS, NSNS, or Lambda API, so kicking off Lambda or API gateway would be crazy useful to support without having to hack it himself. So
sure,
yeah.
Sure, yeah. I think that we could create some solutions around the current infrastructure we have. But what we have done, specific technical detail, is we put the output of our async workflow into a Kinesis stream.
Right.
And we are expecting you to build the consumer for the Kinesis stream.
Right.
My sense is that we could work with our really smart SAs and get you, I'm going to put him on the spot here, and get you a Kinesis stream consumer that you could just pull up and plug in.
Yeah.
On the other side, for the live stream, which we, to be again technically correct, we only support face search, face recognition with live stream. Mm-hmm. The output goes into a stream that you provide us, and you could just read that as well. So the async process, the get call gives you the payload.
Right.
For stream processor, it's a Kinesis stream that you provide us, we stream data out of.
Right. So I'm just going to throw a scenario out there, because when you were talking, I'm thinking about, I already have like a stream or a consumer for streaming video using Kinesis, right? Because of course I've been kind of hacking around with it. Don't tell anybody. So I'm thinking, what if we use the same type of? Is it possible? Because I'm again looking at questions. Is it possible for us to have our real-time streaming scenarios with the back end of Lambda using Rekognition video, Kinesis video streams into that kind of architecture? Is that possible?
Absolutely. That's the architecture we support.
Yep.
So if you already have a consumer for a Kinesis stream, just provide us that ARN, that ID, and we'll start spitting out the result to that Kinesis stream that you're already watching. Okay,
see guys, so my code already works, so you can go out there and try that. I know we have to wrap up soon. We got a couple of minutes, but I want you guys to say if there was anything that these guys out here could do for you guys to not only help us to make the service better, but to really create some really cool, compelling things. This is your time to tell them to get on it.
Yeah, absolutely.
If you need feedback.
I mean, we are very excited about the product, no question. You could see it. The thing that I would request you guys to play with is, I think, sensors, right, for your home. Play with building a person detector and with real time. And then what you could build is, if family or friends are approaching your home, you could pull pranks on them and know who they are. And in my home, I want to build over the weekend something so my doors can open themselves because I have a smart lock. So I would love to see that getting played out, and I'd love to get feedback, because I know we have built this, we have played with this, we are very excited about it. Would love to try, you guys try the person tracking, because it's really, really powerful. So if you have family, tracking a senior at the home or kids at the home, or if you're trying to look at public safety to see, in areas around you, you can track people. Face recognition to identify family and members. Would love to see these things the support of live stream and person tracking.
Okay.
It'll be awesome to get some feedback from you guys.
Okay, right.
All right.
I have my demo already in my head planned to do. So as we go out, if you would kick off, let's play his video one more time. They asked on the stream.
Yeah, one more.
Yeah, just 10 seconds because everyone asked for it. Guys, we'll be here streaming other cool things. We are so glad that you're here with us. Please keep pinging us in questions on the stream. That's what we're here for. And check out the blog posts and the links to this new exciting service. All right.
Thank you.
Thanks for coming.
Thank you.
Bye, guys.
Bye.
See you later.